conditional probability. You're going to be hearing me say given that so many times throughout this video and throughout this section. Given that, it's basically saying here's a total of something. However, we're going to just focus on this people. An example, if I said, given that a person's female in the classroom, we're not going to count the males. We're just going to look at the total females. So it changes the outcome of the total outcome. So for this first problem, when I'm reading through this, what this actually is saying right here is what's the probability someone is female? This line means given that they graduate from school. So this is almost like the fraction that you're setting up. This given that's your total. So given that they graduate from school, so here's, or graduate school, sorry. So given that they are in graduate school, that's my total. So I take 1,349 and add 1,954. That's my total outcome. So there are 3,303 people. What's the probability that they would be female? So on top would be the 1954. And especially in these cases with the given that, I would probably always have the answer as a percentage, 3303. So this would be 59%. 59%. Now the second question is saying, what's the probability that you pick someone at random and they're female? So this is not a given that. This is saying, here's all the people. This is my total. What's the probability that's female? So first thing you have to do is add up all those numbers. So my total there, everyone in that chart would be 17,472. Now this is saying what's the probability, knowing everyone's there, that you pick a female. So this is all the total female. So this is not a given that. So now I add those all up. I get 9,933 and divide that by my total. And again, with the larger numbers, I would do this, and this would be 57% chance. So I want you to try to do this C by yourself. Now this has a given that. So given that they're male, so you for sure know that they're male, what's the probability they also have a 4-year degree? So here it's saying what's the probability that a sample of recycled waste. So this is almost a different way that you could write the previous type of problem. So you know for sure it's recycled waste. So given that it's recycled, what's the probability it is paper? So the 4502 should go on top, and then your total recycled. So that would be 79.4, my total recycled, which would be 57%. If you had recycled paper, a recycled item, that it would be paper. So I want you to try to do B and C by yourself. So this is just another way that you can look at it. Think about this. The given that, so the probability of the second thing, that total probability on bottom, and then on top is the two happening together. Given that probability of A happens, what's the probability A and B? So utility company asks 50 of its customers whether they pay their bills online or by mail. What's the probability the customer pays their bill online given that they're male? Given that they're male, so here's the total males, so that would be 20. What's the probability that they paid online? So knowing that the probability of A, for sure that they're male, what's the probability that they're male and online? So it'd be 12 out of 20, which would be 8 out of 10, which would be 4 out of 5. Or you could say 80% chance. And then last but not least is this question B all by its lonesome right here. And I want you to do that question all by yourself because you know what? You're smart. You're Mr. Mrs. Smarty Pants. So that's why you can do it by yourself. And then after you do that question by yourself and you're like, hey, look at this. I'm so smart. Then you can go on your merry way and have a great, grand, wonderful day.